The NOR gate is a circuit that outputs a logic 1 when two inputs are 0. Starting from the most basic logic gate will allow us to incorporate it into the creation of a more complex digital circuit later. This is the truth table that shows the behavior of the NOR gate for different combinations of inputs. When two inputs are in the off state, the output will be on. The output will be off when either or both of the inputs are on. Now let's see how we can create this NOR gate with artificial neurons using our platform FEAGI. FEAGI is an open source platform that enables neuroscience principles to be used for robotics. To learn more about FEAGI, please check out the link in the description. You can create the two inputs in the NOR gate using the Add New Cortical Area feature. For cortical area type, select Custom. You can give the cortical area whatever name you want. For demonstration purpose, I will name this input A to match what we have in the truth table. Here you can select the dimension that you want for the cortical area. For simplicity's sake, we will keep all the cortical areas as 1 voxel. Then you can set the location of the neuron by inputting XYZ values. Before setting any parameters in the neuron, I will create the other input neuron and the output neuron following the same steps. Now connect the two input neurons to the output neuron so we can see how changes in the input can impact the output by adding an ether mapping here. I will select output as the destination cortical area. Then in the mapping definition, I will choose block to block as our rule. By having PSP multiplier as a negative value, the input neuron will have an inhibitory effect on the output neuron, meaning that it will inhibit the output neuron from firing. Now we will change the parameters within each input and output neurons to ensure our NOR gate is functioning as what is stated in the truth table. First, we will wire the brain power to the output, so rule 1 of the truth table is satisfied. Power is something that supplies continuous stimulation to the selected destination. Now let's set the postsynaptic potential of the input neurons and the firing threshold of the output neuron to satisfy the other conditions for NOR gate. Postsynaptic potential is how much of an influence that the input neuron is going to exert on the output neuron. In order to have the output neuron to not fire when either of the input neurons is activated, we need to set the postsynaptic potential of each input neuron to be greater than the firing threshold of the output neuron. I will set the firing threshold of the output neuron to be 50, and the postsynaptic potential of the two input neurons to be 100. Remember, we have a negative number as our postsynaptic potential multiplier, which will make the 100 into negative 100, thus inhibiting the output. Now pressing down the Shift key and clicking on the neuron will allow you to manually stimulate the input neuron. So when either of the input neurons is stimulated, the output neuron will be turned off. Of course, when both inputs are stimulated, the output neuron will also be off. Now our NOR gate is all set. Let's see how it behaves again. Thank you for watching.